Students, good morning. I am so happy to see you once again after a long back through this CETEL channel. Today, I am going to discuss about the concept of wet bulb temperature. What is the definition for wet bulb temperature? What is the principle behind the definition of wet bulb temperature? Before going to proceed, what is the definition for wet bulb temperature or how wet bulb temperature is defined? Wet bulb temperature is nothing but it is a steady state temperature. It is a steady state temperature reached by a small amount of liquid water by evaporating into a large amount of unsaturated air vapor mixer. This is a perfect definition for wet bulb temperature. Wet bulb temperature is nothing but it is a steady state temperature reached by a small amount of liquid water by evaporating into a large amount of unsaturated air vapor mixer. Let us discuss how this definition is formed. Clear? Before entering into this discussion, I want to recollect what is meant by dew point temperature and what is meant by dry bulb temperature. Clear? Right. For this, let us consider a container. Seems to be like this. A container seems to be like this. That means a balloon shaped arrangement or a container. Subject to the condition, the mouth of this container should be opened to ensure pressure inside the system, pressure outside the system. So total constant pressure or constant total pressure. Condition is constant total pressure. Clear? Now the temperature of this air or atmospheric air at present condition, this is completely unsaturated. That means it needs still more water vapor. Clear? At present condition, this atmospheric air is unsaturated. That means this air is not sufficient with this water vapor present in that. Clear? So unsaturated air vapor mixer. Unsaturated air vapor or gas mixer. A temperature ordinarily measured by the thermometer is called the dry bulb temperature. This is the ordinary temperature of air. Okay, same air is filled with this container. What I am trying to do is I am going to make a cool environment around the system. This is called a system. I am going to make a cool environment around the system. What I am trying to do is I am going to decrease the temperature of this unsaturated air vapor mixer. Unsaturated air water vapor mixer. Clear? Right. Upon continuous spraying the highly chilled water or cold water around this setup, temperature inside the system goes to decrease. To what extent this temperature will decrease? That means this unsaturated air vapor mixer becomes saturated. The excess water vapor will be condensed. There will be a formation of dew. First dew. At what temperature this dew formed? The temperature is called as dew point temperature. This temperature is called as dew point temperature. So wet bulb temperature, dry bulb temperature is the ordinary temperature of this unsaturated air vapor mixer. dew point temperature is nothing but temperature at which the first dew formed, or dew point temperature can be stated that it is the lowest temperature of air. Still, if you are decreasing the temperature, there will be a formation of dew. So, at what temperature the first dew formed out of contact with the liquid? The first dew, formation of first dew is called as dew point temperature. For this explanation, I am in need of dry bulb temperature as well as dew point temperature. Now, you are very clear what is meant by dew point temperature. Dew point temperature is the temperature at which the first dew formed, or you can say that this is the lowest temperature of air by evaporative cooling. Okay. So dew point temperature is known, dry bulb temperature known. Now let us going to perform a simple experiment. Let us consider this is a pipeline. This is the transparent glass pipeline. In this pipeline, unsaturated air flowing very rapidly. Assume that unsaturated or advanced air flowing very rapidly. Now I am going to place a drop of liquid water in this rapidly flowing. I am going to place a drop of liquid water in this rapidly flowing or a current of rapidly moving unsaturated air vapor mixer. This air vapor mixer is called as unsaturated air vapor mixer. So what I am trying to do is I am going to place a drop of liquid water in this stream of rapidly moving unsaturated air vapor mixer. Okay. Now the temperature of liquid water initially, if the temperature of this liquid water initially, if it is greater than that of this dew point temperature, what I am trying to say is I am going to place a drop of liquid water in a rapidly moving stream of unsaturated air vapor mixer. Now the temperature, if it is greater than that of dew point temperature, if it is greater than that of this dew point temperature, it indicates the vapor pressure of liquid water. Vapor pressure of liquid water is greater than that of partial pressure of vapor in this unsaturated air vapor mixer. That means vapor pressure is greater than that of partial pressure. It indicates that this liquid water will evaporate. The condition is if the temperature of this liquid water initially greater than that of dew point temperature, it indicates the vapor pressure of liquid water is greater than that of partial pressure of moisture present in the unsaturated air vapor mixer. If vapor pressure is greater, then this liquid droplet will evaporate and diffuses into this air. Clear? I think now you are very clear. Evaporation means it is phase change. The heat required for evaporation or phase change is called as latent heat. Clear? For evaporation, this liquid water or water droplet needs latent heat. Initially, this latent heat, listen carefully, this latent heat is supported by the sensible heat of the liquid water. For evaporation or phase change, the heat required is called as latent heat. For evaporation, this latent heat is contributed by sensible heat of the liquid water. Now my question is, to what extent the sensible heat of the liquid water will be contributed? During the expense of sensible heat, listen viewers, expense of sensible heat. Expense of sensible heat causes to decrease the temperature of this water droplet. For evaporation, the heat record is called as latent heat. For latent heat, it is supported by initially the sensible heat present in this liquid droplet. To what extent it contributes its sensible heat? During expense of sensible heat, the temperature of water droplet goes to decrease. The temperature of water droplet goes to decrease. To what extent this temperature will decrease? That means if the temperature is equal to this dry bulb temperature, the temperature of water droplet, if it is equal to dry bulb temperature, the contribution by water droplet, contribution of sensible heat by water droplet will be stopped. There is no more expense of sensible heat. That means the initial temperature will be decreasing gradually to what extent? Equal to dry bulb temperature. Now the liquid droplet maintain a particular temperature. For still the requirement of heat for latent heat, it is supported by heat transferred from bulk air or unsaturated air. Just listen. Beyond that, the heat required. For heat required, heat is transferred from this unsaturated air vapor mixer to the liquid droplet for evaporation. In this situation, the perfect statement is rate of heat transfer. Rate of heat transfer from bulk air or unsaturated air to the water droplet is equal to rate of heat required for evaporation. Rate of heat transfer, rate of heat transferred is equal to rate of heat required for evaporation. Rate of heat required for evaporation. Clear? Rate of heat transferred from bulk air to liquid droplet for evaporation is equal to rate of heat required for evaporation. In this situation, the temperature of water droplet remains same. The condition is during rate of heat transferred from bulk air to liquid droplet is equal to heat required for evaporation. In this situation, the temperature of liquid droplet is maintained as constant or steady state. This steady state temperature, listen the definition, this steady state temperature reached by a small amount of liquid water evaporating into large amount of unsaturated air vapor mixture is called as bed bulb temperature. Once again I am repeating this, bed bulb temperature is nothing but it is a temperature or steady state temperature attained by small amount of liquid water evaporating into large amount of unsaturated air vapor mixture under constant total pressure. This is the fundamental principle behind this bed bulb temperature. In bed bulb temperature, you must emphasize the statement rate of heat transfer from bulk air or unsaturated air vapor mixture is exactly equal to rate of heat required for evaporation. In this situation, the temperature of water droplet remains same or under steady state condition. The steady state temperature reached by the small amount of liquid droplet by evaporating into large amount of unsaturated air vapor mixture under constant total pressure is called as bed bulb temperature. Under constant total pressure. This is a perfect definition for bed bulb temperature. Thank you. ரொம்ப நன்றிங்க சார்.